let's look at some things about triangles. First thing I want to look at is just a word called altitude. And an altitude, that is actually a line, and it's a line that goes from the vertex, okay, from any vertex, straight down so that you make a right angle with the base of your triangle. That's an altitude. It's really cool, but there's another word, another line I'm really interested in, and that's a word called a median. And a median's a little different. A median is when I look at the base, I look at the bottom here, and I find the midpoint, I'll just say it's about there, and I go from the vertex right down to the midpoint. Now, these are different. Sometimes, like on an equilateral triangle, they'll end up being the same. But as you'll see, this didn't make a right angle. So they're often different. Let's take a closer look at the median. So looking here, we've got a midpoint. So if we want to find the median, we've got to first find the midpoint, okay? And so to do that, you just kind of draw it in, and then we're going to use this little equation, this algebraic equation, to find the midpoint. So go ahead and find the midpoint for this line here so that we can then draw the vertex to there. When you do that, you do all that work, you'll see that the median is 11, 0. So I'll just write that as 11, 0. Not the median, the midpoint. And then I can draw my median line. Now, there is not just one median because I could do it for every single side. So we actually have 3 medians. So for each of these, I can draw my vertex to the middle, find the center. You can do the vertex to the center, and then right here, find the center and do the vertex to the center. When you do that, you'll notice that they all intersect, all right? They'll intersect at this point, and it's a special point. We call that middle of the triangle. The word that we use for the middle of the triangle or the point of intersection is centroid. Okay, so that's the word that we're going to use to describe this single point. And it's kind of cool if you take a closer look. You'll notice if I look at this line, for example, from the vertex to here, if I look at this distance, it's not the same as the distance from the midpoint. And you'll notice that on all of these. If I take a ruler, okay, you'll actually see that this side would be about 2 of these. And it's like that on each side. So all of the centroids, for the centroid, on each of these lines, the ratio is 2 to 1 from the vertex. This comes in really handy if I want to figure out what is the XY coordinate of the centroid. So let's look at how we do that. So if we want to find the XY coordinate, we'll start here. We've gone this far, right? We found our midpoint already, and I've got my vertex. Awesome. That's step 1. I'm going to just pick one line. Since it's the same on every single line, whichever one I use, I just pick one, and this one looks like an easy line to use, this median right here. And I want to find that one that is got that 2 to 1 ratio right there. Okay, so I'm kind of guessing it's here. I'm going to figure out the exact points now. So I'm going to go, I've got my vertex, my midpoint. Next, step number 2, I calculate the centroid using that 2 to 1 ratio. So this is the equation. The point is closer to the midpoint. The midpoint has a bigger influence, so I multiply it by the bigger fraction. This one is further away, smaller influence, smaller fraction. Go ahead and figure out what the centroid is. When you do the work, you should come out with 11 2/3 and 2. So I can go right back here, and I will label this 11 2/3 and 2, and that will hold true for all of those. So all of these lines will intersect right there.